Welcome to Building Materials, your trusted MEP solution provider in Abu Dhabi.
Butt welding. In this short film, we will tell you how the butt welding is done. While butt welding is made using proper tools is very important for welding to be a long-term and healthy one. Tools we recommend are as follows. 1 machine body. 1 hydraulic unit. 1 heater. 1 trimmer. 2 inserts or pipes and cleaning solution. In case of using large-scaled insert and pipe, 2 or 3 reels are required. Before pipes are connected on machine, part which is length as machine should be cleaned about 50 centimeters in inner and outer of the pipe. Before starting welding process, pipe should be placed onto machine body and reels, and it should be fixed into machine body with clips. Pipes should be connected at least 2 centimeters ahead from medium clips. Medium clips should be tightened until circularity of pipe is corrected and pipe would not move. Outer clips should be more tightened than medium clips. After pipes are connected to machine, place trimmer between pipes. When pressure of the machine is 0, press a head walking button of machine. During this time, increase the pressure gradually. When machine starts to pull the pipes, look at manometer. Pressure you read on manometer is the walking pressure of machine. Make trimming by adding 5 or 10 bars to this pressure. When a complete tour of chip is seen around pipes, it means that trimming process is completed. After the completion of trimming process, do not touch trim surfaces. Keep pipes butt to butt. Be sure that pipes contact each other fully. When pipes are butt to butt, access and circularity of pipes should be controlled. If pipes are not within access or there is circularity in pipes, lose one of medium clips and tighten other clips and adjust access and circularity of pipes. Find diameter and PN value of pipe you will weld in the chart. Press continuously to a head walking button of machine. Before pipes come butt to butt, you will see walking pressure. When pipes are butt to butt, you will see total pressure by adding welding pressure to walking pressure. For example, if walking pressure is 20 bars, welding pressure is 28 bars. Total pressure should be 48 bars. Rotate the pressure regulator clockwise. Adjust total pressure by adding walking pressure into welding pressure, according to how welding pressure is in the chart. Heaters should be plugged in while trimming. when trimming process is completed. Trim surfaces should be cleaned with cleaning solution. When indicator reaches 220 degrees Celsius, place the heater between pipes and give pressure up to welding pressure by pressing onto a head walking button. Wait until lip is formed in both sides of heater. Melting surface around the heater will start to rise. When adequate lip is formed, reset the pressure from pressure resetting lever in hydraulic unit. After the pressure is reset, tighten pressure resetting lever. Wait up to T2 period stated in the chart. When T2 period is up, open the machine by pressing on back walking button continuously. If you press onto a head walking button instead of back walking button, you should conduct all processes over again. Take the heater from between pipes quickly. Press a head walking button of machine continuously and join pipes butt to butt. When melted surfaces of pipes are approached each other, you will have reached welding pressure by pressing a head walking button intermittently. After pipes are welded each other, do not remove the clips immediately. Find cooling period in the chart and wait up to the period stated in the chart. Your risk-free choice in welding machine is Turan
Building Materials, your trusted MEP solution provider in Abu Dhabi.
EF installation step-by-step spigot joint welding. When joining by electrofusion, the use of appropriate tooling is crucial for the welding of long-lasting, reliable joints. Our recommended toolbox includes the following items: a sharpened hand scraper for small diameter pipe, a measuring tool, an indelible marker, a spanner, a pipe centralizer, a rational pipe cutter, lint-free wipes, re-rounding devices, special cleaning solution for PE welding, a rational scraper, electrofusion welding machine, and a high-quality bore-fit fitting in its original packaging. Sand and mud shorten the lives of cutting blades and should therefore be avoided. The first thing to do is to clean the pipe with water in order to remove abrasives from the surface. Don't forget to dry the pipe with a lint-free cloth. The correct cutting tool will give you a good joint and also a clean and square cut. We recommend you to use pipe shears for small diameter pipes and rotational pipe cutting tools for large diameters. The pipe must be measured and marked to prepare for scraping. Measure half the length of the fitting. Add 2 cm and mark the pipe. When using the hand scraper, mark the pipe as shown here. Good scraping will make those marks disappear. When you're done, chamfer the end for easy pipe insertion and make sure to remove all the scrapings. Mark the pipe this way when using a rotational scraper. Make sure all the marks disappear. And don't forget to chamfer the pipe in to remove the sharp edges. At this point, it's important to mark the true insertion or the stab depth. Measure the length from pipe stops to fitting end and mark it on the pipe. Oval pipe can be an obstacle to forming a high-quality joint. Much of the pipe we encounter is not perfectly round, and rerounding is therefore an essential step of the process. This is especially true with large diameter pipe. As shown here, clamps are placed close to the insertion depth mark in order to reround the pipe end. The final step before installation is cleaning and degreasing. This is performed with a special cleaning solution for PE electrofusion welding, as any other fluid may do damage to the joint. To apply the solution, use clean lint, scratch-free wipes, or wipes made from fabric or paper. It is absolutely necessary to clean all the welding surfaces. Once these surfaces have been cleaned, you should not touch them with your hands. Since a clean, dry surface is fundamental to good welding practice, Borefit provides fittings in sealed plastic bags. Remove the fitting from its original packaging only when you are ready to degrease it and install it on the prepared pipe. We recommend that you clean the fitting as well, even when it is in original packaging. Be sure the pipe is fully inserted into the fitting by checking the location of the stab depth marking as shown. Borefit recommends the use of a paper centralizer for the dual purpose of relieving stress in the joint and preventing joint movement during fusion. Use of pipe centralizers reduces the risk of short circuits and ensures trouble-free fusion. Also, be sure to cover the ends of the pipe as shown to prevent the uncontrolled movement of air during welding. Now that we've completed the preliminary steps, we turn our attention to electrofusion welding machine and generator. First, make sure the fuel tank of generator is full. Then start up the generator. This is important for making sure that welding is not interrupted. Connect the electrofusion welding machine to generator. Then connect the terminals to the fitting. The fusion time may be set by a self-recognition resistor. Other options include a barcode reader and manual input. The correct fusion time is shown on the barcode label on each fitting. Be sure to check that the fusion time in the controller screen is identical to fusion time on the barcode label. For the duration of fusion, cooling the joint is sensitive and should be left undisturbed. Leave pipe centralizer and rerounders in place. At the end of fusion, you may carefully remove the terminals, making certain not to move the fitting. Take good care of the terminal ends and cables. They carry high current loads and should be kept clean and dry. The correct cooling times shown on the barcode label on each fitting. At the end of the cooling, you may dismantle the rerounding equipment and pipe centralizer. When fusion is complete, mark the dismantling time on fitting. This is equal to the present time of day plus the cooling time. Since pressure testing requires low temperatures in the joint, we recommend waiting 4 times the cooling time after fusion before beginning pressure testing. Get it right the first time. If you follow the instructions in this short film, you should achieve excellent long-lasting joints. Turan Borefit, your risk-free choice in welding machines. Our representatives are always at
Green Building Materials, your trusted MEP solution provider in Abu Dhabi.
The I-joint comes ready to use. It's fast and easy to assemble and designed to fulfill high safety standards, from 20 mm up to 110 mm in size. When pushed in, the pipe passes the lip gasket and compresses it, pushing the pipe further to the end stop. With a few turns, the fitting is tight. The special NBR lip gasket performs outstandingly well, even with overlised, scratched or undersized pipes. In cases of tensile stress or water hammer, the pull-out resistance is guaranteed because the special design of the clamp ring ensures a perfect grip on the pipe. Assembly is quick. No unscrewing is needed. Cut the pipe and push it into the fitting. When you feel resistance, you've reached the gasket. Push further to reach the pipe stop in the fitting. Up to 32 mm, the nut can be fixed by hand. For larger sizes, use the George Fisher key or a standard wrench. I-joints of 75 to 110 mm in size have a different compression system. Cut the pipe square and deburr it without chamfering. Push it into the fitting. When pushed in, the pipe passes through all the components without any interference till it stops. With a few turns, the fitting is tight. The nut causes the clamp ring to grip the pipe and the thrust ring to compress the gasket. In cases of tensile stress or water hammer, pull-out resistance is guaranteed because the special design of the clamp ring ensures perfect clamping on the pipe. I-joint, the optimal compression fitting for simple, fast, and reliable installation. The perfect solution for several applications such as industrial and house connections, service lines, and high-end irrigation systems.
Green Building Materials, your trusted MEP solution provider in Abu Dhabi. Building Materials, your trusted MEP solution provider in Abu Dhabi. Building Materials, your trusted MEP solution provider in Abu Dhabi. Building Materials, your trusted MEP solution provider in Abu Dhabi. Building Materials, your trusted MEP solution provider in Abu Dhabi.
What exactly is a VFD? Well, it stands for Variable Frequency Drive. They are used for running an AC motor at variable speeds, or let them ramp up their speed to give them a smooth startup. Some people simply call them drives. They work by adjusting the frequency of the motor to adjust the RPMs. To do this, a VFD will actually convert the voltage twice. First, it converts our three-phase AC to DC. This is accomplished with diodes. Then it cleans the DC with a capacitor. Next, it will convert the DC to AC. This is accomplished with transistors acting as switches. Utilizing these switches is what allows the VFD to adjust the frequency that the VFD supplies to the motor. This, in turn, controls the speed of the motor. Now, I know this is a lot of information to take in. Let me compare the internal workings of the VFD with a simple plumbing system. First, let's look at the diodes that convert the AC to DC. This operates like a check valve in a water system. A check valve, like a diode with electricity, only allows water to flow in one direction. The capacitor acts as a water filter to keep everything clean and usable. The transistors act like valves. They turn the flow on and off when needed. This allows the VFD to adjust the frequency of the motor. Now that we have an understanding of how a VFD works, let's see what they're used for. One very common use in industry is to control the speed of a water pump in a water treatment facility. A water treatment plant typically has a constant flow of water coming into the plant. However, if the water demand exiting the plant is lower than the supply entering the plant, then the operator will need to slow down the supply. This is achieved by using a VFD on the AC motor. The operator can monitor water flow and manually adjust the VFD accordingly. Another great thing about VFDs is the fact that they can be controlled with a PLC. Using basic communication protocols that have been covered in previous videos, such as RS-232 and RS-485, PLCs can monitor and control motor speeds using the VFD. This helps make a process like water treatment that much easier and more efficient. This setup can be used in any situation that would benefit from automation. Let's look back at what we now know. VFD stands for Variable Frequency Drive. They are used for controlling the speed of an AC motor. They are also used for ramping up a motor for a smooth startup, or to prevent a heavy load from straining the motor on startup. This is accomplished by adjusting the frequency delivered to the motor. A setup of an AC to DC converter, then DC to AC converter. VFDs are used throughout industry. A common example is to regulate water flow entering a water treatment plant. VFDs allow the operator to control the flow of the pump manually or automatically with a PLC.
Welcome to Building Materials, your trusted MEP solution provider in Abu Dhabi. Building Materials, your trusted MEP solution provider in Abu Dhabi.